For those of you that weren't in class today, I'm feeling nice and I'm going to record this for you. So hopefully you took the time to try to figure this stuff out because these are Regents types problems, all right? Most likely on the Regents you won't see a question that looks like this. You're going to see more of a question that looks like this, converting something into vertex form and then utilizing the information given. Okay, so in the video from the last one, I do go through number 5, and so I did that one in class today, but anyway, if you're lost on these, make sure to ask those questions in class, okay? I can't decide whether you're confused on something. You have to decide, and you have to let me know. Okay, so just keep that in mind. Anyway, here we are, taking some quadratic applications, vertex form, and then putting them into practice in some real-world scenarios. Okay, so a bottlenose dolphin jumps out of the water. The path the dolphin travels can be modeled by this equation right here, where h of d, or your y values, okay, your output, represents the height of the dolphin in the air, and d represents the horizontal distance. Give me just a second. I got to clear my throat. Excuse me. Okay, hopefully that sounds a little better. I don't like I have a frog in my throat. So, h of d represents your output. All right, represents the height of the dolphin, and then d, or your x values, or your input, okay, represents the horizontal distance. Okay, so it's worth mentioning that the start of this guy is going to be at the origin. Okay, and so your y values are measuring how high your dolphin jumps in the air, and then your x values is measuring distance, how far it jumps in the air. Okay, so that's what our x and y are measuring, and it's important to put out that we are starting at the origin, right? If I plugged in a 0 for d, well, everything goes away, and so when x is equal to 0, y would be equal to 0. Okay, so it's worth mentioning, okay, just to stay in practice with the information on these bad boys. Okay, so that being said, okay, we're going to take this equation and we're going to convert it into vertex form. Okay, so the first thing I'm going to have to do is I'm going to have to factor out that negative 0.2. So by doing so, I end up getting this. Okay? But what's nice about this equation, and let me go get my, actually, yeah, let me go get my calculator. Hold on. Okay, so here we go. All right, so actually, what's nice about this problem is we could leave it like this, but 2 divided by 0.2 actually turns out to be a nice number. Okay, and actually get a 10 for that. So let's change that. Okay, because I don't want to look at a 2 over 0.2, right? How about minus 10? Doesn't that look a little nicer than what we had before? Okay, and so now we're ready to complete the square, right? Looking for that perfect square trinomial. So I'm going to go negative 10. I'm going to take my b value, divide it by 2 and square it. So negative 5 squared is equal to 25. Okay, now here's what we've been kind of practicing though, right? I can't just add 25 to the side of an equation, right? Or just to one side of the equation, right? I would have to add it to both, but I don't want to add it to both. And so in order to accompany for that, whatever I add inside this parenthesis, right, I must account for on the outside. I must balance this equation, okay? So let's think about this though, right? What's this times this? Well, if I were to factor this in here, right, we'd get that negative 0.2d squared, okay? That would become just a positive 2d, right? But 25 times a negative 0.2 is equal to a negative 5. Okay? And we don't want that negative 5 here because, again, all right, when we multiply this all out, when you distribute everything, we want to be left with the same equation, and so that we're not changing the value of anything. So to make up for that, if I'm subtracting 5 inside the parenthesis, then that means I need to add 5 on the outside. Okay, and then so finally, h of d is equal to a negative 0.2. This is just going to be d minus 5 squared plus 5. Questions asked, what is the maximum height? Okay, so it's asking for what is the maximum y value or output that we would get. And we get this from our vertex. Our vertex here would be 5, 5. And so our answer, the maximum height the dolphin reaches, is going to be 5 units. Okay, because Mr. K forgot to put some units on there. So 5 units. Right? We still have to make sure that we're practicing labeling these answers here because they're word problems. Okay, let's take a look at number 7. You and a friend are hiking in the mountains. You want to climb a ledge. Okay, that is 20 feet above. The height of your grappling hook is given by this function. Okay, so what we're looking for is we got this ledge, all right, it's 20 feet up, okay, and I got this grappling hook that I'm trying to throw in order to catch that ledge, all right? And so this right here is my trajectory for me throwing that hook, okay? So let's think about this, all right? So when we put this in vertex form, we're looking for whether or not our vertex, more importantly the y value in our vertex, is it larger than 20? Okay, so that is our goal for this particular problem here. So let me write this out. Now what's nice about this problem and the next one is that these numbers, 128, 32, are multiples of 16. So we're going to get some nice numbers here, guys. So that's something to be excited about. All right, so I'm going to factor out a negative 16. So this is going to be t squared plus 2t plus 5. Again, I'm not changing the value of anything in this equation here, okay, because if I were to multiply this through, I would certainly get the same thing up top. Okay, so that is our goal through these. We are not changing anything in the equation. We want to make sure that when we multiply everything out, we still get the same thing we had before. Okay, let's take our b value, divide it by 2 and square it. So 1 squared is going to give me 1. And so h of t is equal to negative 16 t squared plus 2t plus 1 plus 5. Now, here's where it gets tricky. If I were to multiply this out through, okay, I would certainly get this right here. Okay, but what's negative 16 times 1? Well, I would end up getting t squared plus 2t, I'm sorry, let's multiply that out. Try this again. Negative 16t squared minus 32t minus 16, okay? And then we'd have plus 5, okay? So that's certainly not the same thing we had before, right? And so in order to accompany for that, what's throwing us off is a 16, so I'm going to add 16, and that sort of kind of balances our equation out. Okay, so add 16 here. And again, I just get that by multiplying this number and this number right there. Okay, and then finally, whoops, not 17, hey-oh, plus 21. And so the question's asking, now this is our vertex. Remember our vertex here is just negative 1, comma 21. Okay, but the question's asking, all right, use vertex form to find if your grappling hook will reach the ledge. So this is the max value, this is the max height of our y value for when I throw this grappling hook. So our max value is 21, and so our ledge is 20. So we can say, yes, we will reach the ledge, okay, based off of this guy in vertex form. Okay, last but not least, very similar problem, except for this time we're talking about a rocket shot off a cliff, 101 feet in the air, all right, with an initial velocity of 128 feet per second. Okay, so our first move is to plug that stuff in. Okay? That's our first move. All right, this 128 represents our initial velocity. 101 represents our initial height. And we just sort of plug that in into our equation like we did up above. Okay, for that one, number 5. So anyway, now take out a negative 16, so it's going to be t squared minus 8t plus 101. Keep writing 100. Take my b value, negative 8 divided by 2 and square it. Okay, so I'm going to add 16 in there. But really, what am I adding? I'm not really adding anything. I'm actually subtracting, right? If I multiply this through, I get negative 16 squared minus 8t minus 256 plus 101. Okay, so ensure that I get the same thing I would get up above if I were to multiply this out. Keep writing 100. Is if I add 256 at the end. Okay, so that's what we're going to have to do in order to balance that guy out. Finally, let's put this in vertex form. $357. And so, finally, use vertex form to find out when the rocket reaches its maximum height. So our vertex here is just 4,357. And so our x values represent our time, right? So when does the rocket reach its maximum height? Well, we would say 4 seconds. All right. And what is the maximum height? Well, 357 feet. And that is it. Okay, so hopefully for those of you that are quarantined, or maybe you're watching this because you needed some reinforcement on some problems, okay, hopefully this helps you guys. Okay, good luck, you guys.